Hello guys, welcome to Java Core Programming course. This is lecture 6 of section 1 and this will be the last lecture for this section. In the next video, I will start section 2 based on branching, conditional statements and loops. Let's begin today's lecture. So today's agenda is casting, explicit and implicit casting, assignment operator, OOP assignment operator, bitwise operators and shift operators. Let's begin. Casting. Typecasting is when we assign or convert one data type to another. Java supports two types of casting: implicit, that happens automatically, and explicit, that we have to do it. Otherwise, there will be a compiler error. Implicit casting occurs between shorter or narrower data type to larger or broader data type. For example, int to n, int to long, float to double. On the other hand, explicit casting occurs when we cast broader data type or larger data type to shorter or narrower data type. For example, long to int, double to float, int to byte. We have to cast it explicitly through programming. It does not happen automatically. If we do not cast it, it will end up in compile error and program does not compile. In explicit data type casting, we have to use the cast operator, that is parenthesis and data type. For example, byte b is equal to 5 and int I is equal to 3. And if we assign I, that is an integer, to the byte, we have to cast it to the byte data type. And to cast, we need parenthesis and data type name. Okay, another thing, at the time of casting, in the previous lecture, I have discussed overflow and underflow errors. If there is a bigger data type, data value that cannot be stored in a byte or a short or an integer, casting it will lose the precision or the value. Maybe it will result in a junk value. So make sure when you cast some value or some larger data type value to a shorter data type, you must consider its size, how many bits it can store. Okay, assignment operator. Java uses equal to sign for the assignment of a value to a variable or a constant. So whatever comes to the left side of assignment operator is L value, and whatever comes on the right side of the assignment operator is R value. R value is always assigned to the L value. Variables can be assigned values anytime during the lifetime of the program. That is why we call them variables, because their values can change during the runtime of the application. Constants can only be initialized once and don't change throughout the program. Constants can be initialized inside a method and inside a loop scope or through inside a constructor, class constructor. We will discuss this when we start object-oriented programming. So Java also provides OOP assignment signs, where OOP can be bitwise operators, arithmetic operators, or shift operators. For example, plus equal to, that is, add two values and assign it to the left side operand. Divide equal to, and equal to, that is bitwise operator, bitwise AND operator, and right shift equal to, that will right shift the operand and assign it. There is only one assignment operator, if it comes alone, this one. There are total 11 OOP equal to or OOP assignment operators. 5 combined with arithmetic operators. There are 5 arithmetic operators and we can combine them with the assignment operator. There are 3 bitwise operators and OR and XOR. We can combine them with the assignment operator. The fourth bitwise operator, that is tilde, the complement operator, cannot be used here because complement operator is unary operator that operate on single operand. And 3 combined with shift operators. There are 3 shift operators: left shift, right shift, and unsigned right shift. These 3 operators can also be combined with assignment operator. So there will be total 11 OOP assignment operators in Java. These are shift operators: right shift, left shift, and unsigned right shift. Okay, now bitwise operators. All integer variables are internally stored as a binary base 2 numbers that are consist of zeros and ones. Java provides 4 bitwise operators that operate on binary bits. These operators are AND, OR, XOR, that is represented by the caret sign, and tilde, the complement operator. Truth tables. AND operator is a binary operator, only true if both operands are true. In case of bits, result is 1 only if both side bits are 1. This is the truth table for the AND operator. For example, if we have operand A and operand B and their values false, false, result in false. Sorry, this should be A and B. False, true, result in false. True, false, result in false. True, true, result in true. That is the only combination of A and B that will result in B and B, A and B is equal to true. Okay, now OR operation. OR operation is represented by the pipe sign, single pipe sign. So it is also binary operator. Any operand true, the result is true. Or if it is operating on bits, any bit is 1, the result is 1. So here A, B, A or B. So false, false, false. That is the only combination when A or B will be false. All the other combination false, true, true, false, true, true, all result in true values. Okay, now XOR operator. XOR operator is represented with the caret sign. This is typo. Consider it XOR operator. That is represented by the caret sign. So binary operator, both sides are different. It is true. Otherwise false. In case of bits, if both bits are 1 or 0, result is 0. Otherwise 1. So false, false. If A is false, B is false. Result is false. A false, B true, result is true. A true, B false, result is true. A true, B true, result is false. So when both bits are same, are the true or both values are true or both values are false, result will be false. That is the XOR operation. Now the bitwise operator continued, and we are discussing complement operation. Complement operator is represented by tilde. Tilde is a special character that is that operates on single operand, and it converts 0 to 1 or 1 to 0. It, in other words, we can say it inverses the value. So false becomes true, true becomes false. 0 becomes 1, 1 becomes 0. And it's truth table. A, and because it operates on single operand, so we have only one operand here. So true becomes false and false becomes true. Now the shift operators. Left shift operator. This shift the significant digits towards the left and fill the number with 0 bits. Right shift. This shift the significant digits towards right and fill the number with the signed bit. So this is a signed right shift. This is unsigned right shift. It shifts the number towards right and fill the number or pad the number with zeros. There is a significant difference between these two operators. This will not change the sign. Negative number remains negative, positive number remains positive. This will change the sign. Positive will remain positive and negative will become positive. Okay. These operators are used in the form operand, operator, and number. Operand is the variable that we are going to operate. Operator is the operator, one of these three operators, and the number of bits we are going to shift. For example, some variable and left shift operator 2, it will left shift the variable 2 positions towards left and pad the number with 2 zeros from the right side. Hello guys, let's let's practice lecture 6 concepts. Create new file, lecture 6. Add new method, main method, public static void main and string parameter. Okay, let's create few variables. Okay, byte, let's say b is equal to 3, short s is equal to 9, int I is equal to, let's say 4. Okay, the first concept, casting. Okay, implicit casting. Let's print the values. B is equal to S is equal to and I is equal to BSI. Okay, we can reuse this statement to print the other. Something is wrong. Okay, we need F, formatted output. Okay, so implicit, we can automatically cast shorter or smaller data type to the larger one. So I is equal to 3. Sorry, I is equal to B. Okay. I is equal to S. This is also okay. Let's print the value side by side. And print here again. Okay. Let's run it. Okay, see, we have B is equal to 3, S is equal to 9, and I is equal to 4. And then we assigned B byte to the I, and it becomes I is equal to 3. Then we assigned S to I, and it becomes 9. So we do not need any special casting to cast a shorter or smaller data type to a larger one. But in case of explicit casting, okay, I is equal to, let restore the original value. Okay, B is equal to I, error. S is equal to I, error, because we cannot cast larger data type to a smaller data type automatically. We have to cast it. So to cast it, we need cast operator, and parenthesis is the cast operator, and inside it we write the data type name and short. Okay, now we can no error after casting, no error after casting. Okay, let's print the values and let's run it. Okay, so we have the updated values now. So guys, keep in mind, shorted data type can be implicitly or automatically casted to the larger data type, but larger data type must be explicitly casted to the shorter data type. And keep in mind, if there is a larger value, the result will be a illogical value. Let's test. Overflow. Okay, let's say I is equal to max value. Okay, we cast it to short. Okay, print. Let's print here so that we know the maximum value of I is there. Run it. Okay, okay, so I, we store the maximum value of integer into I, that is 2 billion something. That is max value is equal to 2 power 31 minus 1. That is the maximum value of an integer. So we casted it. Casting operation is okay. Casting is okay and legal. But question is, overflow will result in invalid value. So our answer will be wrong. And due to overflow, it becomes -1, negative value. So whenever you perform a conversion through casting from larger data type to the shorter data type, you must consider the maximum value of the target data type so that your results will not affect. Okay, now next concept, assignment operators. We already used it lot of times. We assign right hand value to the left hand value. Okay, let's see OOP equal to operators. There are, as I mentioned in the video, 11 OOP equal to operators. So we can combine, let's say I plus is equal to B. Legal conversion as arithmetic operation make byte to integer while arithmetic operations. So it will run. Okay, it works fine. And this value becomes overflow. So let me change the value of I. I is equal to 4. So that we can see the accurate result, because we stored maximum value, added byte, the byte value is 3, so it result in overflow. Run. So now we have I is equal to 8. 4, how it becomes 8. B is equal to 4. B is equal to 3 and 4. Okay, B's value is 4. Somewhere we have altered the values, so it becomes B is equal to 4, and we stored I4 here. So 4 plus 4 is equal to 8. S is still, let's change S. S is equal to 3, let's say. Okay, so we have a valid value in the short variable. Similarly, we can use other variables. Okay, let's try bitwise operators. Okay, so we have I is equal to Let's reset them. B is equal to 2, I is equal to 5, and S is already equal to 3. Okay, now let's print values as binary. Okay, system dot out dot print percentage S percentage D in binary. Okay, percentage N. Okay, B is equal to byte dot 2 let's over integer to binary string. Okay, we can promote it. Let's say it comes, we take two integer values, int x is equal to 5, int y is equal to, let's say, 7. Okay, so x and x. Second value y, and this is also y. So let's print it. Run file. Okay, so 5 in binary and 7 in binary. The integer is 32-bit data type, and the leading zeros are not displayed. Okay, so consider there are these numbers are 3 1 0 0 1 2. Okay, 3, and there will be 29 more zeros on the left hand side. Okay, let's operate. Int result is equal to 5, let's say, and y. Let's see what is the result of this value. Result and result. Okay, so 7, these are two binary numbers, 5 and 7, and these two bits are 1. So AND operator truth table, 2 bits are 1, result is 1. 2 bits are 1 and result is 1. In the center there is 1 bit is 0 and other bit is 1, so result is 0. So it becomes 101. 101 is equal to 5. Okay, now OR operation. OR operation, any bit is 1, result is 1. So we will get 7, because 7, all 3 bits are 1. So 2 bits are 1, result 1. 1 bit is 1, result 1. And again 2 bits are 1, result is 1. Let's make some bigger number so we will have a different results. Let's say 11. Okay, run. Okay, here, see, we have 101 and 1011. So when we did the OR operation, we get 4 ones. And when we did the AND operation, only first bits are same. So first bit is only 1. Now the XOR operation. In the XOR operation, when there are two same bits, they become 0, and alternate bits becomes true. So caret sign, and let's see the result. Okay, this is the result of XOR operation. In the XOR operation, first bits in both the operands are 1, so that become 0. Other 3 bits are different, 1 0 0 1 and 1 0. They are true. So this is the answer for the XOR operation. Now the complement operator. Okay, complement operator operates on single operand. So we will use, let's say, y, sorry, tilde. Okay, tilde operator. Tilde operator converts the bits from 0 to 1. So we have y. Y value is 11. This is y. So see, first 4 bits, 1 converted to 0. This one is also converted to 0. This 0 converted to 1. And this 1 is converted to 0. These are first 4 bits. Rest of all the bits up to 32 bits are 0 in this number. So they are converted to 1s. And this is sign bit. Sign bit is for the negative number. So it becomes minus 12. Okay. Now shift operators. Okay, let's set our values again. X is equal to 5 and y is equal to, let's say, 17. Okay, now left shift. Okay, we use binary numbers. Okay, this will be x and y and y. Let's print them to see their binary pattern. Okay, these are our binary pattern. 5 in binary number and 17 in binary number. Now we will do the left shift. So y is equal to y left shift 2. Left shift y 2 bits. Okay, let's see what is the answer. Let's make it result. So we keep the same numbers. Result. Okay. Run. Okay. See guys, this is the number 17. And we left shift 2 bits. So 2 zeros are padded. After padding 2 zeros, it becomes 68. Because these are the significant numbers. When we shift towards left, they multiply or they add up. Now right shift. We right shift 17 2 bits. Okay, after right shift, run the file. Okay, see, after right shift, we shifted, this is the number, we shifted these two discarded and we left with 100 and 002 bits are padded from here. So no sign changed because this is a positive number, and in signed right shift the sign bit remain same, only zeros are padded. So we left with these three numbers 001, they become 4 because these are binary numbers. So basically right shift sign shift is a division. Now unsigned the in the unsigned right shift. Okay, let me run it, then we will discuss. Okay, see, the result is same result, no change here. Why no change? If both these numbers, both these operators, signed right shift, unsigned right shift, produce same result, why do we have these two operators? That is a big question. So how they work, you need to understand. This is signed right shift. This will pad the this will pad the signed bit from right side, so from left side. So positive number, sign bit is 0, and it will keep on padding sign bit from the left side. If the number is negative, the sign bit is 1, so it will keep on padding 1 from the left side. In case of unsigned right shift, for the positive numbers, this operator will pad 0 from left side. In case of negative number, this operator again pad the 0 bit. If it pads 0 bit into a negative number, that number will become positive number and will be a very big number. Let me show you an example. Okay, we have minus 17. Okay, we have a negative number and we run it now. Okay, see here what happens. Negative numbers, ignore these, because these two are the operate on signed numbers. Okay, so minus 17 shifted 2 points towards left and 2 zeros are padded and number decreased. Minus 17 becomes, number increased, become minus 12. In case of signed right shift, here we have 17, this number, y is 17. Okay, we printed y here, and let me write it here so clarify. Run the file. Okay, so we have this y 17 in binary. This is the negative number, so we right shift 2 decimal points, so sign bit added, these 2 bits are discarded. This is here, so these 2 bits are discarded and we left with these 4 last bits, and rest of the number is same, and its padding is signed bit. The for negative number, signed bit is 1, so it becomes minus 5. In case of unsigned right shift, okay, we discarded these 2 numbers and last 4 numbers remains here, these 4 bit patterns, and we padded it with zeros, so number changed into positive number, and this is a very big number. 1 2 3 and 4 5 6 7 8 9 and 10, 1 billion something. So minus 17 unsigned shifted right toward 2 bits becomes a 1 billion plus number because of padding of 0 instead of signed bit. That is all, guys, for the bitwise operators and shift operators. I hope you have learned a lot, and if you have some questions on this section, please comment under the videos. I will reply. And in the next section, I will start branch statements, if else, switch statement, and for loop, while and do while loop, and assertions and other control statements. Thank you, guys. Please subscribe to the channel and enjoy. Have a good day. Thank you.